Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving minimum time to repair cars. So the problem states that we are given an integer array ranks and it represents the ranks of some mechanics. And each rank shows that it can repair n cars in r times n squared minutes. So we are given an integer called cars representing the total number of cars that needs to be repaired. And we will return the minimum time that is needed to repair all the cars. So if we look at this example, the minimum time taken would be 16 minutes. Because if we look at it, we will give the first mechanic 2 cars to fix, which will take 16 minutes. We will give the second mechanic also 2 cars to fix, but it will take 8 minutes since the second mechanic's a little bit faster. The third mechanic will also give him 2 cars, so it will total to 12 minutes. And the last mechanic, we can give him 4 cars since he's a bit faster and he can do it in 16 minutes. So that is the minimum time, which is 16. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use binary search. So we will set the left and right pointer and they represent the time that it may take to repair the number of cars needed. So the left pointer will always be 1 and the right pointer will be the maximum time possible, which would be the maximum number in ranks times cars squared, since the formula is r times n squared. So for this example, it would be 400 because 4 times 10 squared is 400. And what we'll do at each binary search is find the middle value. And in that middle value, we will find the number of cars that we can possibly repair in the time frame. And how we will do that is we will take the square root of time divided by rank, and that will tell us the number of cars that we can repair. Because if we look at the formula, it is rank times cars squared. So to find the number of cars that we can repair, we will just take the square root of time divided by rank. So if the number of repairs is equal to cars, or if it's greater, then we can set the result to the middle value, and then we can shift the right pointer, which would be middle minus 1. However, if the number of cars that is repaired turns out to not be enough, meaning less than the cars variable, then we need to shift the left pointer because it means that we will need more time. So shifting the left pointer would be setting left to middle plus 1. And after the pointer meets, we will return what's in result, which is the minimum value that can repair the number of cars needed. So let's go over this example. So first, we will try 200, which is a middle value between left and right. And in 200 minutes, we realized that we can make 39 repairs. So basically what I did for each of these elements is I did the square root of the middle value divided by the element in the ranks array, and I added them in total, and it showed that we can make 39 repairs. If you want to calculate them on your own, feel free, but for the sake of time, just know that we can do 39 repairs in 200 minutes. And also one more thing, when we did do the calculation, we always need to round down to the nearest integer. So since 39 is greater than 10 cars, it means 200 minutes is more than enough, so we can shift the right pointer. So now the right pointer is 199 and the left pointer is still 1, so the middle value is 100, and we see that it can make 27 repairs, which is enough time, so we can change the result to 100 and shift the right pointer again. Now after shifting right pointer to 99 with the middle value of 50, we can still make 19 repairs, which is enough, so change the result to 50 and shift the right pointer again. Now that the right pointer is 49, we see that with the middle value of 25, we can make 12 repairs, which is still enough, so we update results and shift the right pointer again. Now with a middle value of 12, we see that it can only make 8 repairs. So we don't update results, but we need to shift the left pointer. So now that the left pointer is 13, the middle value will be 18. In 18 minutes, we can actually make 11 repairs. So it is enough. So we shift the right pointer again, and we need to update result. Now with a middle value of 15, we can only make 8 repairs. So the result would be stay at 18, but we need to shift the left pointer. Now with a middle value of 16, we can actually make 10 repairs, so we can update the result to 16. And now we shift the right pointer, but after we shift the right pointer, we realize that the right and left pointer have met, so we can end the binary search and return 16 as our result. And the time complexity would be O of n log m, where n is the number of elements in the array, and m would be the maximum value on the right pointer, so it would be the maximum value on ranks times the number of cars squared. So that would represent m, because that is what we're doing binary search on. And to find the number of repairs, it will take n time because we need to iterate through ranks. And the space complexity would be O of 1 because we are not using any extra space. So now let's get to the coding part. So first we will set the left pointer to 1, and we will set the right pointer to the max of ranks times cars. And initially, we will initialize the result to 0. And while left is less than or equal to right, so now this is our binary search. We'll set the middle value to left plus right divided by 2. The number of repairs, we'll initialize it to 0 each time. And we're going to loop through ranks, and we will do repairs plus equal the integer of the square root of mid divided by r. And if the number of repairs turns out to be greater than or equal to cars, then we can shift the right pointer and update result. Otherwise, we can shift the left pointer instead, and we can return result after that. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.